find my note. All right, 3-2, day 1. We're going to talk about conditional probabilities. Here it's the probability of an event happening given that a condition has occurred. Condition. And the condition most times will reduce your sample space. I'll say sometimes. Reduce what would be the normal sample size. And we have some special notation for conditional probabilities. Let's do it in this way. It's the probability B/A. And the way you read that is you're asking what's the probability that B happens given that. That vertical bar means the phrase given that A has already happened. So this says find the probability of event B given that A has occurred. So you got to ask yourself, does A reduce my sample space? And then use that as your new sample space. So ask, does event A reduce the sample space? So let's take a look at some good conditional probabilities and you'll see how it can reduce the sample space. Okay. What's the probability that you pick a heart from a deck of cards? So that notation would look just like, what's the probability that you pick a heart? So has my sample space been reduced here from a deck of cards? Absolutely not. So what's my sample space for a deck of cards? 52. How many hearts were in that deck again? 13. Or you could have told me right off the bat that what fraction of the deck are hearts? 1/4. Okay, I'm going to change it up now. Can you find the probability that you pick a heart given that you only have the red cards. So there's a condition that's been met here. Now my deck only consists of the red cards. So first of all, let's look at the notation for this, and then we'll do the probability. So the notation would look like, find the probability of picking a heart, given that, and this would say red, and you'd need the notation here, or the sentence to say that, oh, I'm only picking from the red. So what's happened to my sample space? Is it still 52? What is it now? 26. There's only 26 red cards. The 13 diamonds and the 13 hearts. Or you could have told me 1/2. Okay. Let's get rid of this. Now we're going to pick 2 cards from a deck of cards without replacement. So you're going to pick a card, keep it, go back in and pick a second card without replacement. So I want you to find the probability that the second card is a queen, given that the king was the first card out of the deck. So I'm not going to write that out in a sentence, but I wrote it in notation. So I'm looking for the probability the second card is the queen, given that the king has already been drawn out first. So does this condition change my sample space when I go to pick my second card? What's my sample space? 51. So my sample space has been reduced down to 51 cards, because the king is now out and in my hand. How many queens are left in that? There's still 4.
This is what was tripping me up when I was trying to solve the power problem.
Oh, is it?
Because each time you can only have one number
Right.
in each thing.
Right, you can't repeat. What's the probability that the second card is the queen, given that the first card was a queen? Figure out that probability, please.
It's, like you're starting with 52. Right?
Yep, we're still starting with 52, but one's already been drawn. The second one's the condition. That's the first card out. This is the second card. So what's this one going to be?
3 out of 50.
3 out of 51. Any questions on that? Oh, I should have got some newer data with this stuff. Oh, I can just switch the names on here. Okay. Tables. Okay, we'll go Republicans, Democrats, Clinton, Trump. And then our total. Okay, we'll go 55, 36, oh geez, I got to do this right. 55, 36, We need 12, 24. Okay. See if this works. Okay, so this was a poll before, what?
Just as if more Democrats might be wrong. Just go along. Sorry, my bad, all right.
Yeah, we're just gonna go with it, 'cause it's different, I had Bush and Gore on here, I didn't laugh. It's not real data, so yeah, I do, yeah, that's bad. But anyway, we'll go with it. Okay, so how many people said they would vote for Clinton? We have a total here of 36. For Trump? 91. How many Republicans did they talk to? 67. How many Democrats did they talk to? 60. If you add vertically here, it better match what we add horizontally. Does it? 127 this way, 127 this way. You'd be surprised, you'll have like 2 or 3 of these kinds of questions on your SAT, where they'll give you a table of data and ask you probability questions, so you definitely want to get good at these. So we're going to randomly pick one person from this group here. Okay? Randomly pick one. What's the probability that the person you pick was a Republican? So the first thing you need to ask yourself is, what's my sample space? How many people am I picking from? How many people are we picking from? 127. How many were Republican? 67 total. So it's 67 out of 127. What's the probability that the person you pick says they're going to vote for, or said they were going to vote for, Trump? Okay, so again, has our sample space switched at all? Still 127. And the Trump voters were 91. I'm going to write the next one in a sentence, because that's where you're going to see it on your SAT. What's the probability that you pick a person, let's see, probability that the person chosen is Republican given that they are voting for Trump. So you see that phrase in there, given that. That's a condition that's being met. Probably going to reduce your sample space. Does this reduce my sample space?
Yes.
So what is my sample space that I'm looking at?
91.
The Trump voters, given that they are, so technically in symbols now, but again, they don't give you the symbols on the SAT, they give you the sentence. If it was me, I'd probably chicken scratch real quick. The probability that the person is Republican, given that they're voting for Trump. So Trump is my sample space. How many Trump voters were there? 91. And it's so, you know you're really only looking at that Trump column. If you get rid of the rest of it, cover up, you can't mess this up. There's only 3 numbers there to work with now. You're only looking at the Trump people. So then how many are Republican? 55 out of 91, easy. So on the conditional ones, if you cover up the rest of the table, you'll 99% chance you're going to get it right. So 55 out of 91. We're going to keep going here, because these are the ones people do terrible with, even on the quiz. I'm going to write the sentence, because I think that might help. So the next one, same table. What's the probability, given that the person is Republican, they vote for Trump. So in symbols, how would I write that? The probability of what slash what? Looking for Trump, given that Republican. So the condition that's met is, I am definitely looking at only the Republicans. So, if you go to your table, your Republicans are this horizontal row. Cover up the other two rows. You're not going to use any of those numbers. Our sample space now is what? 67, and the Trump voters, 55 out of 67. Okay, I'm going to have you do the next one all on your own. Find the probability that the person is a Democrat, given that they voted for Trump. See if you can get that one on your own. Did you come up with 36 out of 91? Is that what you should have gotten? Trump is your sample space, so find your Trump column. Good? Everybody else? Okay, moving on then. Moving on to independent events. Two events are independent when the outcome of one event does not affect the probability of the second event. But if the first event does change the second one's normal sample space, they're called dependent. So dependent events when the first event reduces the normal sample space of the second event. So before we get into the probabilities, we want to talk about just if you can tell the difference between two events that are independent and dependent. You didn't have it? Number 4. Tell me if the two events are independent or dependent. So you really only have to look at the second one's sample space, what its normal sample space is, and see if the first one reduces it. So my second event is rolling a die. What's my sample space for rolling a die? How many are there? 6. When I flip a coin, is it going to reduce the number of outcomes on the die? Absolutely not. There's still going to be 6 sides to that die no matter how many times I flip a coin. So these two events are independent. Event 1 is going to be to pick a card from a deck of cards, but then replace it. Put it back in the deck. So with replacement. Event 2 is going to be to pick a card. So that second event, what's the normal sample space for picking a card? 52. Does event 1 reduce this sample space? If I pick a card, but then I put it back in the deck, has my sample space been reduced for the second draw? So these two events are independent. Here we've got event 1, pick a card. Without replacement, you're going to keep it. Event 2 is pick a card. So here, normal sample space you told me was 52. But if I pick a card without replacement, what's the sample space now? Gets reduced down to 51. So it did change the second one's sample space, so these are dependent events. Okay. The reason we talk about those two big ideas of conditional probabilities and independent versus dependent is so that we can now find the probability of 2 or more events happening in sequence. So it's event 1 happening, followed by, so the connecting word is and, because we're going to do some ors in a couple days and the formula's going to change. Event 1 happening and event 2 happening. And you could have a third event, and ... Events happening in succession. So, in the way you do probabilities of successive events happening, you multiply those probabilities together. So the probability of A happening and B happening you just multiply the two probabilities together if A and B are independent. But if they're dependent, you got to remember to change the second one's sample space. So the formula looks like this. I always just think about them as dependent, and I'll show you why. Because then you won't forget to change that second one sample space. Good? We're on our last example. You made it to the end here. Number 5. You're going to pick 2 cards. Without replacement. What's the probability that you pick a pair of kings? Now it's important that you can rewrite this in your head or on paper as either an and situation or an or situation. Because once we get them all mixed together, that'll be the challenge. So right now, what's another way I could say this, these 2 events happening? What's the probability of getting a king and a second king? So once you can take this phrase and turn it into an and, you know you've got to multiply the probabilities together. And my formula says, yes, multiply. So it's the probability the first one's a king. But the second one is conditional on the first one happening. So that means a king, given that a king has already been drawn out. The second one needs to be conditional on the first one. So, we go in. What's the probability the first card you draw out is a king? 4 out of 52. Now, we assume that that did happen. You've got the king in your hand. What's the probability now that you get a king, given that you've already got the first king out? 3 out of 51. So, if you talk through it in your head, you're going to know to reduce that second one sample space. And then whatever that comes out. You guys can do that part later. What's the probability that you get a heart followed by a diamond? So that's the probability of a heart and a diamond. In about 2 minutes. Probably less than that. So it's the probability the first one's a heart, and then the probability the second one's a diamond, given that I drew out the heart. Go ahead and write those 2 probabilities down. And then I'm going to write the last one while you finish that, and then we'll help that girl. Okay, do C also. Heart, heart, then spade. Tell me what you get. What were your 2 fractions for part B? Did you get 13 out of 52? What's your second probability? You agree with 13 out of 51? And then this one, the last one, it's 3 events happening, so you just keep multiplying all the way through. So it's the probability of a heart multiplied by the probability of a heart given heart multiplied by the probability of a spade given heart and heart. You multiply those 3 probabilities together. You don't have to do the final answers on the notes here. You can just save that for homework time. So what's my first probability? Heart is... What's the second one?
12 out of 51.
And the third one?
13 out of 50.
Very good. Okay, page 119. 1 through 10, 14 to 16.